We often think of microwaves as a modern invention. They seem so futuristic. But the story of the microwave oven stretches back further than you might think. It all began with a serendipitous discovery. In the 19th century, scientists stumbled upon a new form of electromagnetic radiation. Microwaves. This discovery wasn't planned, it wasn't even expected. But like many scientific breakthroughs, it happened by accident. This spark in the dark would eventually revolutionize the way we cook and live. This unexpected discovery opened a new chapter in the world of physics. Scientists were eager to understand this invisible force. They conducted experiments, they formulated theories. Little did they know their work would lead to the microwave oven sitting in your kitchen today. The journey of the microwave is a testament to the power of scientific curiosity. It shows how unexpected discoveries can change our lives in profound ways. Two brilliant minds played a crucial role in laying the foundation for the microwave oven. First, we have James Clerk Maxwell, a Scottish physicist. In the 1860s, Maxwell developed his groundbreaking theory of electromagnetism. His equations predicted the existence of electromagnetic waves. These waves, he proposed, could travel through space at the speed of light. Maxwell's work was purely theoretical at the time. He didn't have the means to prove his ideas experimentally. That's where Heinrich Hertz comes in. Hertz was a German physicist working in the 1880s. He was fascinated by Maxwell's theories. Hertz set out to prove the existence of these elusive electromagnetic waves. In a series of ingenious experiments, Hertz generated and detected electromagnetic waves. He demonstrated that they could travel through space just as Maxwell had predicted. Hertz's work confirmed Maxwell's theories. This was a monumental achievement in the history of science. Fast forward a few decades, and the world is embroiled in World War II. Technology is advancing rapidly. Scientists and engineers are working tirelessly to develop new tools for the war effort. One such innovation was radar. Radar systems used microwaves to detect enemy aircraft and ships. This technology proved to be a game-changer during the war. Little did anyone know that this wartime innovation would soon find its way into our kitchens. The development of radar was crucial for the evolution of the microwave oven. It wasn't just about detecting enemy planes. Radar research led to significant advancements in microwave technology. Scientists and engineers gained a deeper understanding of how to generate, control, and manipulate microwaves. This expertise would prove invaluable in the development of a revolutionary new kitchen appliance. The story of the microwave oven takes a delicious turn in 1945. Percy Spencer, an American engineer at Raytheon, was working on a radar-related project. One day, while standing near a magnetron, the device that produces microwaves in a radar system, Spencer felt something strange. He noticed that a chocolate bar in his pocket had melted. Intrigued, Spencer decided to investigate further. He placed a bag of popcorn kernels near the magnetron and watched in amazement as the kernels popped into fluffy popcorn. Spencer had stumbled upon a revolutionary way to cook food. Excited by his accidental discovery, Spencer and his colleagues at Raytheon set about harnessing the power of microwaves for cooking. They experimented with different foods and designs. In 1947, Raytheon introduced the Radarange, the first commercially available microwave oven. It was a far cry from the sleek countertop models we have today. The Radarange was a behemoth, standing over 5 feet tall and weighing over 750 pounds. It was also incredibly expensive, costing around $5,000 in today's money. Despite its size and price tag, the Radarange marked the beginning of a culinary revolution. Despite its initial limitations, the microwave oven slowly began to gain traction. Over the next 2 decades, engineers worked tirelessly to improve its design and make it more accessible to the public. The bulky Radarange underwent a significant transformation. Engineers developed smaller, more efficient magnetrons. They also found ways to reduce the overall size and weight of the oven. These advancements led to the first countertop microwave ovens in the 1960s. By the 1970s, microwave ovens had become significantly more affordable. Mass production techniques further reduced manufacturing costs. This made microwave ovens accessible to a wider range of consumers. People were initially hesitant to embrace this new way of cooking. Many were skeptical about the safety of microwaves. However, as microwave technology improved and safety concerns were addressed, people began to recognize the convenience and speed that microwaves offered. By the end of the 1970s, microwave ovens had become a common sight in kitchens across the developed world. A modern marvel, innovation continues to heat things up. The evolution of the microwave oven didn't stop there. Over the years, we've seen continuous innovation in microwave technology. Manufacturers have introduced a wide range of features to enhance their functionality and convenience. One notable advancement is the development of the convection microwave oven. These ovens combine traditional microwave heating with a convection fan. The fan circulates hot air throughout the oven cavity. This allows for more even cooking and browning of food. In recent years, we've witnessed the rise of smart microwaves. These internet-connected appliances offer a range of advanced features. Some models allow you to control your microwave remotely using a smartphone app. You can preheat the oven, adjust cooking times, and even receive notifications when your food is ready. Other smart features include voice control, automatic sensor cooking, and integration with other smart home devices. Unlocking the science how microwaves really work. But how do these magical boxes actually heat our food? The science behind microwave ovens is fascinating. It all comes down to the interaction between microwaves and water molecules. You see, water molecules are polar. This means they have a slightly positive end and a slightly negative end. When microwaves pass through food, they cause these water molecules to vibrate rapidly. These vibrations generate heat. This heat is then distributed throughout the food through conduction and convection. Unlike conventional ovens, which heat food from the outside in, microwave ovens heat food from the inside out. This is because microwaves can penetrate deeper into the food. This unique heating mechanism is what makes microwave ovens so efficient for reheating and defrosting. It's also why microwaving can sometimes result in uneven cooking. If the water molecules in the food are not evenly distributed, some parts of the food may heat faster than others. Revolutionizing the kitchen, the impact of microwaves on society. The microwave oven has had a profound impact on society. It has revolutionized the way we cook and eat. Microwaves have significantly reduced cooking times. This has freed up valuable time for busy individuals and families. They've also made it easier to prepare quick meals and snacks. No longer do we need to rely solely on conventional ovens or stovetops for our culinary needs. The convenience of microwave ovens has also had a significant impact on the food industry. The rise of microwavable meals, snacks, and popcorn has transformed the way we consume food. Microwave ovens have made it easier than ever to enjoy a hot meal or snack in minutes. This convenience has come at a cost, however. Some argue that the widespread availability of processed microwavable foods has contributed to a decline in home cooking and a rise in unhealthy eating habits. The future is cooking potential advancements in microwave technology. As we look to the future, we can expect to see even more exciting advancements in microwave technology. Researchers are constantly exploring new ways to improve the efficiency, functionality, and safety of microwave ovens. One area of focus is the development of solid-state microwave generators. These generators offer several advantages over traditional magnetrons. They are more energy efficient, more compact, and have a longer lifespan. Another promising area of research is the development of microwave ovens that can analyze the composition of food. By determining the moisture, fat, and protein content of food, these ovens could automatically adjust cooking times and power levels for optimal results. This would eliminate the guesswork from microwave cooking and ensure perfectly cooked food every time. The future of microwave technology is bright. With continued innovation, microwave ovens will continue to play an important role in our kitchens and our lives.